Welcome to This Explainer. Today, we're going to learn exactly how to save our Java programs from those fatal, hair-pulling runtime disasters. We're focusing entirely on how Java exception handling works, really unpacking the nuts and bolts that keep your code alive and kicking when things inevitably go wrong. All right, let's dive right in. So here's our roadmap for today's rescue mission. First, we'll look at when good programs crash. Then check out the exception family tree. After that, we'll open up your error handling toolkit, map out the exception handling flow, and finally, wrap up with acing the Java interview. All right, section 1, when good programs crash. Have you ever watched your program just die? We all know that sudden jarring dread, right? You've written your logic, compiled it perfectly, you run it, and then bam, it's just gone. See, without intervention, when a runtime error occurs in Java, the program simply terminates. It doesn't ask for permission, it just completely stops dead in its tracks. And this right here brilliantly illustrates that pain. It's the classic divide by zero disaster. Imagine you declare integer A as 10, integer B as 0, and you try to divide them. What do you get? That dreaded red text of doom in your console, java.lang arithmetic exception /by0. Without a safety net, your program stops immediately, right at that exact line. Any brilliant code you've written after that point, completely ignored. Just poof, gone. Well, the official solution to all this abrupt chaos is exception handling. This is essentially a mechanism in Java used to handle runtime errors so that the normal flow of the program is not interrupted. Instead of just blowing up, it allows your program to continue gracefully. It intercepts the error, maybe logs it, and just keeps the engine running. This is absolutely crucial because it drastically improves your program's reliability. Moving on to section 2, the exception family tree. To defeat these runtime monsters, we kind of need to map out the villains first. In Java, everything stems from object, which leads down to the throwable class. From there, we hit a major fork in the road. On one side, we have errors. These are super serious, fatal problems, like an out-of-memory error. Honestly, things you generally cannot and really shouldn't try to handle. But on the other side, we have exceptions. These are the handleable problems. This includes your everyday runtime exceptions that pop up while your program is actually running. Now, the crucial point here is understanding the divide within the exception family itself. Basically, we have checked exceptions and unchecked exceptions. Checked exceptions are heavily policed by Java right at compile time. The compiler literally forces you to prepare for them. Think IO exceptions or SQL exceptions. You absolutely must handle them or declare them. Unchecked exceptions, on the other hand, well, they strike at runtime. Handling them is technically optional from the compiler's perspective, but as we just saw with our divide by zero disaster, yeah, ignoring them is a massive recipe for disaster. Which brings us to section 3, your error handling toolkit. Okay, it's time to open up your developer utility belt. First up is the try block. Think of this as a hazardous work zone. You're literally telling Java, hey, I'm going to try to execute this risky code. Please keep an eye on it. So any code that might generate an exception, like reading a file or doing some sketchy math, goes right inside these curly braces. And right below that hazardous work zone is your safety net, the catch block. If things go south in the try block, the catch block swoops in and intercepts the following program. It catches the exception, handles the error, maybe by printing a nice user-friendly message like cannot divide by 0, and allows the rest of your program to just keep executing normally like nothing ever happened. Then we have the finally block. This one is your guaranteed cleanup crew. It executes no matter what happens. Whether your try block succeeds perfectly or an exception triggers and gets caught, the finally block is gonna run. That makes it the absolute perfect place for essential cleanup tasks. Like closing files, shutting down database connections, or releasing resources. Next up, we have two keywords that are honestly incredibly easy to mix up: throw and throws. You use the word throw, singular, inside a method to actively and explicitly trigger one specific exception, like throwing a new arithmetic exception if someone gives you bad input. But you use throws with an S, plural, up in the method's signature. This declares that a method might unleash potential exceptions. It's basically a warning sign for anyone calling the method, telling them, hey, you better be prepared with your own try-catch blocks. All right, section 4, the exception handling flow. Let's see how this builds into an actual chronological sequence. The flow is actually wonderfully logical. Step 1, you enter the risky try code. Step 2, Java asks, did an exception occur? Now, if no, it skips straight down to the finally block. But if yes, we hit step 3, where the catch block steps in to handle it.
Then, regardless of which path we took, step 4 kicks in, we always run the finally cleanup crew. And step 5, we safely reach the end. The normal flow of the program is completely preserved.
And finally, Section 5, acing the Java interview.
To wrap things up, let's treat this like a rapid-fire boot camp. Here's a quick cheat sheet of the most common exceptions you are totally going to be tested on. You've got arithmetic exception, usually from dividing by 0, null pointer exception, everyone's favorite headache, from trying to use a null object, array index out of bounds exception from, you guessed it, hitting an invalid array indexed, and number format exception from bad number conversions. Knowing exactly what triggers these specific runtime events is absolutely crucial for proving you actually understand how this stuff works in practice.
Now, listen to this question. Can we have a try block without a catch block? This is a classic trick question that interviewers absolutely love to throw at you. If catch is the safety net, can you actually have a try without it? Believe it or not, the answer is yes. A try block can actually be followed by a finally block without any catch block at all. You are completely allowed to attempt risky code and immediately clean up using finally, even without catching the specific error. So try followed by finally is perfectly valid Java. Now, the exception won't be caught, so it will still bubble up and eventually terminate the thread, but hey, your cleanup code is absolutely guaranteed to run before that happens. Okay, what about multiple catch blocks? Yes, again, you can absolutely set up multiple catch blocks for a single try, but here is the golden rule you cannot forget. Your more specific exceptions must come before your general exceptions. If you put the general exception class first, it's just going to catch everything. Your specific blocks below it will become totally unreachable code, which, actually scratch that, it won't even run. It'll cause a compile error straight away. So ultimately, what this all boils down to are a few core advantages. Employing these techniques prevents abnormal program termination for sure, but maybe just as importantly, it completely separates your error handling from your normal business logic. Instead of a messy spaghetti code of if-else checks cluttering everything up, you get clean, readable, and highly robust applications. It really is a game changer.
So, as you head back to your own code, ask yourself, try without catch? Are you brave enough to use finally alone? Are you writing software that just hopes for the best? Or are you engineering systems resilient enough to survive the unexpected? Because exception handling isn't just about fixing crashes, It's about designing for reality. Keep exploring these tools, build those safety nets, and make your Java programs truly bulletproof. Thanks for joining me on this explainer.